Thank you for watching Knowledge Academy. Let's take a look at another problem. So let's start. Remember earlier in this course in calculus we talk about different kind of coordinate system. The one is rectangular coordinate, then we have cylindrical coordinate, and then we have spherical coordinate. Right. So if you pay attention in these coordinate, in this coordinate we have everything in x and y form or maybe z form, right? Here we have the quantities are given in the r, theta, and phi form, right? And sometimes we also including z here, so we call it cylindrical coordinate. But we have these four parameters to conclude. But if you technically look into that, these whole both things are under these whole two things are under polar coordinate. And what's the big difference between that? You can have two ways to solve a line. The line can be solved easily by rectangular coordinate. If you have a curve or you have a circle, you have two ways to solve this circle or this curve. Number one is you can use x equals to whatever, or you can use x equals to r cos theta and y equals to r sine theta. What does it do? This guy actually is very amazing that if you're using x and y, you have two unknown, right? If you're using x and y, you have two variable. Number one variable, two variable. But if you solving through polar coordinate system, which is r cos theta, you know the only variable you have here is theta. So if you take different values of theta, theta equals to 0, theta equals to 1, theta equals to 2, dot 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 dot, theta equals to pi, maybe dot dot dot, theta equals to 2 pi. Depends on your need and how big is the arc or curve. You can substitute different values of theta and you can find the value of x and y. So long story short is really a curve equation can be solved much easier by using polar coordinate. Okay, a curve equation can be solved much easier by polar coordinate. The question will be raising how we can transform a rectangular coordinate integrals, or I can not call coordinate, but it says rectangular system integrals into polar coordinate system. Really what we're doing, we're just changing the coordinates. Okay, so today what we're going to learn, that's what you're going to learn today and go from there. So I'm going to go side by side how does it work. In rectangular coordinate, we try to do this. We have a curve like this, right? And what we do, we just make this guy like a little drink, or we can make another way. You can make this curve. If curve is bigger, you can make a differential element like this. We can call this guy dx. We maybe call this y dy. Okay, this is y-axis, this is x-axis. Here in polar coordinate, we have maybe a circle or maybe arc. This arc, I want to solve this arc. And if I want to solve the differential element, my goal is to find differential element. This is my differential element. Okay, when I say differential element, so this is my theta. So this, you have two ways to do it. Number one, you need to take the element along this axis. So you can cut from here to there, and you can call this guy dr. You also need this way, like this way to this way. Remember, we also have two variables here. The only thing here is we're going to be used differently. Here we call it d theta. So this complete thing is theta. So the part of it is going to be d theta. This complete thing is r. The part of it, like a little part called dr. So we need a relationship. We need a relationship. In rectangular coordinate, we call dA equals to dx dy. Here we also need to find a dA, but to make sure dA must be in r and theta form, right? Must be in r and theta form. Write it better. In r and theta form. So we're gonna learn how we're gonna change that one. So what I'm gonna do, for example, I'm gonna be converting here. I'm gonna be taking, a differential element. I'm gonna take a differential element in polar coordinate. I'm gonna see a differential element in a polar coordinate. And how it's gonna be look like? Let's take a look. I have this. And I'm gonna call this one d theta. Then I have to go this way. So I'm gonna just make a line, right? Make a line like here. And I'm gonna call from here to here is my dr or delta r. You can call dr or delta r. Same thing here, you can call d theta or delta theta. So it says delta r, this is delta theta. That is my radius, that is my r. If I go here, I can call it plus minus, because the radius could be plus and minus, just like x and y could be plus and minus coordinate. So I'm going to call it r plus, and here I'm going to call r minus. Now I'm going to be writing here delta r equals to r plus minus r minus, right? That's my delta r. So you take the complete radius from here to there. Maybe let's suppose this is 5, this is 3, so you're going to say is 5 minus 3 equals to delta r, right? That's what it means. So I'm going to be just erase this because this is just for example. I can also write here, and you learned in long time ago, S equals to r theta. That's a formula. What is S? S equals to the circumference of a circle or the arc length. Like this is basically S means how much you're traveling along this path. It's your displacement, or you can call it angular displacement, right? This S means angular displacement, so we use this formula. So what I'm going to do, I'm going to write here this r equals to pi. This r from here I can say is S or theta equals to r, right? Plus r, this plus r, I can call this plus r equals to delta r or 2 pi, because my here in my r displacement is delta r, and how much I travel total is 2 pi. I can write like this, and minus I can also write like this r delta theta or delta theta or 2 pi. Same thing delta theta or 2 pi. Then I'm going to multiply both sides by pi r plus square and pi r minus square. Okay. Out of these, I'm going to be taking a common. Maybe I can take common half delta theta. Inside this pi cancel, this pi cancel. So here is left over is r plus r minus r plus and r minus square. I can expand this formula by this r1 r plus square r minus square by using this identity, and is equals to a plus b, a minus b. I'm going to use this one, same one here. Plus r minus and then r plus r minus. Okay. This one can be used to call it delta r, right? R plus r minus, we already talked about that, how we can call delta r. This one, like this guy and this one, if I add them, if I put them together, that could be the average, right? That could be the average of two, and we can call them r, right? So I'm gonna call this can be r. How? If I have two things average, r minus plus r minus, this one should be equals to r, right? So what I'm going to do, I'm going to be just writing this delta a. I'm going to be writing like this. That is my delta a2. I'm going to be writing like this, and I'm going to say delta a equal to r. R is coming from here to there, r, and delta theta, or delta r, delta theta. I got delta theta. From here is r, and then this delta r, I'm going to bring it first because r delta r make more sense than r delta theta and delta r. So these are two same operator, so I'm going to keep them together. And that is how I transform my dA or delta A into polar coordinate system. So moving forward, every time you see an integral, right? If you see an integral moving forward, like this integral, and you have any value here, you says dA here. If you want to convert this limits into r and theta form, make sure we also convert this delta A into r and theta form. The first impression a student have in their mind is this dA is d theta dr. But don't forget, it's gonna a little bit different. You still always have a r here. And that is the reason I just show you this little derivation to drive how we can came up with this r dr d theta. So bottom line is that moving forward, we always need r dr d theta. Okay. Unit area of a rectangular coordinate, I want to say is unit area of a rectangular coordinate. We used to write here dA equals to dx dy, or dA equals to dy dx. Either way, you can decide it what you want and how you're going to be solving your integral. Here the things are a little bit changed, but fundamentals are pretty similar. I'm going to say unit area in a polar coordinate is going to be same philosophy, T A R T R T theta. You notice one thing, I have only one way to write here. I have only one way to write here because that's the preferred and normal look like, because I have a R here. I don't have any X or Y in the above expression, but once you have a R, the next entity or next term should be the dr. Okay, so this is pretty much the only way I can write this. If you want to write like r d theta dr, you could do that, but they're going to be adding some extra complexity in your problem without much gain. You're not going to gain anything, just including the complexity. Okay, so now take a look on some example how we're going to solve these integrals. Evaluate. R means region, and that is my expression. Where? Remember, I'm going to go back and then rephrase again. The double integral and triple integral can be solved, especially double integral, two ways, three ways. They give you the question. Number one, they give you the mathematical expression like what given right now. The second, the way you're solving it, they just give you the domain definition, telling you about the domain like region R, and then asking you to solve the problem. You have to create the data. Okay. The third one is that a graphical image or graphical figure is provided to you, and that figure is basically the one you're going to watch carefully and develop your own integral equation. So this one we also have a mathematical the definition is given, and they tell you something about R, so you can creating the limit. The reason they're telling you the R is so you can create the limit. Okay, this R, where R, which R, this R is the upper half of a unit circle, is the upper half of a unit circle. Unit means one, circle means circle. What is unit circle means? A circle have radius equals to 1. That is a unit circle. Okay, that is a unit circle. A circle have a unit 1. So what I'm going to do, I'm going to be drawing a my circle here. Go back. And now since I need only half, I can just create in the line. That is my center. I'm going to ignore this portion. I don't need that one. I only care about the top portion, which is this portion. This shaded portion is the one I'm interested to know. This double integral. Okay. So what I'm going to be doing, I'm going to be drawing a line. And line is keep extending, and I'm going to call this R. This line is hitting and cutting this here. The reason I make this R really big, so you can see this point, you can also see this point. Okay. So here, R equals to 0. Here, R equals to 1, because we already talked about a unit circle. So R equals to 1. So at this point, R equals to 1, because the radius of the circle is unit. Here, at this point, theta equals to 0 degree. And if you go back all the way down here, theta equals to 2 pi. Okay. I'm going to be writing my expression. So R1 minus R square dA. I want to rid of this dA. We know dA could be written out by dr d theta. We just learned about this in the previous slide. We also know one expression that x squared plus y squared equals to y squared. And we also know that x and y can also convert into by using these expressions. So these are the expressions I wrote. Make sure you're writing those expressions in every problem. You maybe need these expressions. So what I'm going to do, I'm going to rid of this dA and substitute my value r dr d theta. Since I have r first, right? Since I have r first, I'm going to be substituting here r equals to 0, r equals to 1. Then I have theta, so I'm going to be substituting theta equals to 0 and theta equals to 1. Okay, looks like I'm in a good shape to start this problem, so let's start it to solving this. So what I'm going to do, I'm going to be writing this expression like this: 0 and it's going to be 5. Okay, I'm going to be just writing my expression and solving inside one, and I'm going to multiply this r minus r cube and then dr. Then I'm going to close the parenthesis, says d theta. Okay, let's substitute the values 0, 1, 0, 5. Okay, if I take the integral for this one, it's going to be equal to 0, I, then 1 over 2 r squared plus minus 1 over 4 r4 parenthesis close and 1, 0 d theta. Let's substitute the values so we can simplify it. It's going to be 0 to pi and half. When you substitute 1, is going to be half minus 1 over 4 minus 0 and d theta. Okay, let's take it off and solve it here. So we're going to be just make it simplified before you take the integral. 0 to pi 1 over 4, 1 over half minus 1 over 4 is going to be 1 over 4 and d theta. Okay, now if you take the integral, it's going to be 1 over 4 dot theta and pi 0. Here what we're going to do, we're going to substitute the values. So 1 over 4 pi minus 0, we solve further, is going to be pi by 4. That's my answer. Okay, let me just go to another problem. Find the volume between paraboloid Find the volume between the paraboloid. Z equals to 4 minus x squared minus y squared and xy plane. We know paraboloid, how does it look like if you remember the definition, and we also know how the paraboloid equation look like by recalling our learning for surfaces in a space. Okay, so if I'm going to be drawing this paraboloid, it's going to be look like, I'm going to be draw first. So this is my xy plane. Okay, and if I want to draw the paraboloid, it's going to be look like pretty much like this, right? This is kind of a paraboloid shape, and this guy is my r, right? So what I'm going to do, I'm going to be using few equations before I start anything. So I'm going to be writing here dA equals to r dr d theta. Then I know x squared plus y squared equals to r squared. I also know x equals to r cos theta and y equals to r sin theta. In our problem, the equation is given like this. So I'm going to be writing here 4 minus x squared minus y squared equals to z. Okay, is equals to z. When z have two values, z equals to 0 at here, and then other value I need to find out for the z. Okay, so that's my z. So I'm going to say that 4 minus x squared plus y squared equals to 0, and I can write like this, and I can also write like this. When I'm going to take this, remove this square, it's going to be r equals to plus minus 2. R cannot be positive, R cannot be negative, only positive possible. So I'm going to ignore this guy and only take this one. I'm going to ignore the minus sign because radius cannot be negative. Okay. And the other thing is that this paraboloid is start from here and going all the way down and come back here. So I know theta, this theta goes to 0 to 2 pi. This other one, previous one, we have a 0 to pi. Here we have 0 to 2 pi. Okay. So what I'm going to do, I'm going to be taking my integral and writing the volume. Volume equals to, I'm going to take the z, right? dA, that is my integral. That's what I want to calculate it. And I need to solve this. I can also write this. Our current conditions are like this. Z equals to 4 minus r squared. We talk about that is right here. Then I need to return this dA to r dr d theta. Then I need to return this r region into r, lowercase r, and theta form. So this one is going to be 0 to 2. We talk about that, how we come up with this 0 to 2, r equals to 2. So here at this point r equals to 2. And theta value is 0 to 2 pi. Okay. Let's simplify this before we solve it. So I'm going to be writing volume equals to 0 to 2 pi, then 2, 0. And inside the parentheses, I'm going to be writing 4r minus r cube dr d theta. All right, let's start solving this step by step. So I'm going to be writing 2 pi 0 parenthesis, and I'm going to be writing taking the integral for 4r with respect to r. So it's going to be 4 by 2 r squared minus 1 over 4 r 4. And this is closed. I'm going to put the value, it's going to be 2 0 and outside parenthesis d theta. Okay, let's substitute the value. So 4 divided by 2 is going to be 2, and r squared is 2 times 2 is going to be 4. So 4 times 2 will be 8 minus half. This one is going to be 4 times 4 times 8. 8 divided by 4 is going to be 4. 8 divided by 2. 16 times divided by 4 will be 4. Okay. Then minus 0 and d theta. Let's take the second integral. Before we do this, I think we can write like maybe let's take the integral 4 theta 2 pi 0, and also write 4 2 pi minus 0, and the answer would be 8 pi. That is my point. We were talking about change of variable and how do we convert them in polar coordinate. We did a bunch of examples. We look at the theory and then background. How do we convert them step by step? We did a bunch of problems. So let's continue and practice more problems. In this problem, we need to find the volume between the cone z equals to 9. So the cone is given, or cone equation is given at least, and a plane z equals to 5. Okay. And what's going to happen, I'm going to be drawing these. It's going to be look like we have a cone. This cone is going to be look like a 3D cone. Right, it's going to be like this cone. And in the bottom there is a shadow under here, right? We have another circle, right? If I can make the shadow, it's going to be a circle. Okay. And we need to find the volume between the cone and the plane. Z equals to 5. So if I z equals to 5 means z somewhere here, I need to find out the z value because this is z-axis. And really what I need to find out the volume between these two. And I'm going to be filling this thing so we can understand better a little bit. So I need to find out this volume, this volume, this volume. We all know dA equals to R dr d theta. We also know x squared plus y squared equals to r squared. We also know x equals to r cos theta. We also know y equals to r sine theta. Okay. In this problem, the top, this is my top of the shape, this is the bottom of the shape. Right. The top of the shape is given 9 minus x squared plus y squared. So can I write top equals to 9 minus r? Yeah, we can write like this. The bottom is given z equals to 5. Okay. I can also write from here 9 minus r. So basically at this point, like in the middle, can I write this equation from here that z equals to z, both z's are equals, like z of this bottom and the z of this top should be equals. And I can write like this 9 minus r, which is this, equals to 5. From here, r equals to 9 minus 5, so r equals to 4. And I know r equals to 4 means really this r here, r equals to 4. So this r is 4. You start with 0, go up to 4. Okay, I'm going to make my mathematical expression for this volume. So I'm going to say solution. The volume equals to double integral top minus bottom and r dr d theta. Okay. Now I'm going to be substitute the values. V equals to, let's go from 0 to 2 pi, 0 to 2 pi. And r is going from 0 to 4. We already talked about that. How does it come? Like this. I'm going to substitute the top equation 9 minus this, but I need to substitute in the form r because my expression in dr and d theta. So I'm going to be substituting r, 9 minus r form, minus 5 and r dr d theta. Okay, let's simplify this. So volume equals to 0 to 2 pi, 0 to 4, and then 9 minus, you can write 9 minus something, and maybe we can write directly 9 minus 5 will be 4. So 4 minus r. 4 minus r, but there's a r here, so I'm going to be writing directly. I'm going to say 4 r minus 4 r squared. Not just r squared. Star square, and then I'm going to close the parenthesis dr d theta. I think I'm about to take the integral. I'm ready. Everything looks pretty much simplified. There's nothing more we can do about it. So we're going to write in this one is 4 by 2, right? So 4 by 2 is going to be 2 r squared minus 1 over 2 plus 1 is going to 1 over 3 r cubed. So I'm going to write as is 1 over 3 r cubed. And the limit is 4, 0 d theta. Now, let's substitute the limit. Let's see what does it go. So 2 and then 4 times 4 is 16. 16 times 2 will be 32 minus 4 times 16, 64 divided by 3 minus everything becomes 0 d theta. Let's simplify it if you could before we moving to the second integral. So this one is going to be 3 is going to be 96 minus 64 divided by 3. Okay, 96 minus 64. So 96 minus 64 divided by 3 and d theta. If I move it up here 0 to 2 pi, and this is going to be 32 over 3 d theta. Let's continue. Volume equals to, if I'm going to take this one, it's going to be 32 over 3 theta 2 pi 0. 2 pi minus 0. So if I solve this, it's going to be 32, so it's going to be 64 over 3 and then 5. And that is my volume between cone and z equals to 5. Okay. Let's take a look at another problem. In this problem, you just need to solve this. I don't know if it's a volume, I don't know if it's an area. Double integral is given in the form of some expression. So 9 minus r squared, square root 9 minus squared, and here is 3. I don't know what is what, it's just given to me, so I have to take it as is and solve it. Okay, the function is given sine x squared plus y squared dy dx. Okay, before we start solving this problem, we need to ask ourselves, can we really need polar coordinate to solve this one? And the answer is probably not. We can solve it just like we used to do it. We can convert this x and y in like a substitution method. We can solve this one by substitution method. So what I'm going to do, I'm going to strictly follow with polar coordinate, since this is what we are discussing right now. So I'm going to substitute some values and look like this. I'm going to write in those expression, the one we used to write. And here x equals to r sine cos theta and y equals to r sine theta. In our equation, we have y is given, right? Because this is y, so y is giving 0 and this, so y is giving this. We can also write like this. Oh, no, y is given like this. If it's given in the r, I would be happy. So the problem is that y value is given in the form of r. In order to rid of this dx dy, I need r d theta dr. This form, in order to, I have to completely transform my limits into r and theta form. Okay, so y need to be converted here. So y is equals to this. I'm going to write y squared equals to 9 minus x squared. And I can rearrange this one. It's going to be x squared plus y squared equals to 9. From here, I can say r squared equals to 9 and r equals to plus minus 3. So really r equals to 3, right? We don't ignore it, so r equals to 3 r equals to -3. We ignore this one, we're going to take this value. Radius cannot be negative. Okay, so look like this is a equation is giving from dx and dy. So what I'm going to do, I'm going to draw this expression look like here. If I look into this, look like this, nothing but it's just a circle. And the dx value is going from x, this is y. So dx value go from +3 to -3, it means go from this way to this way, right? So, and that is my r equals to 3. Here, my theta equals to 0 to pi. 0 here, pi here, r 0 here, 3 here. So what I'm going to do, I'm going to take my current expression and then writing like this. Inside one, I'm going to say sine r square. And outside dx dy, which is basically equals to dA, I can convert into r dr d theta. So I'm going to convert into r dr d theta. Here, the value of r limit we already talked about, 0 to 3 and then 0 to pi. Now it's pretty straightforward problem to solve it. So what we're going to do, we know that there is a square in the form of sine r square. If you sine x, sine y, whatever, we can solve it easily. But since r square, we need a substitution. So u equals to r square du over dr equals to 2r. And we need, here, we need to convert this du equals to 2r dr. Okay, so I'm going to be writing my expression. Zero to 3, pi to 0. And here I'm going to be writing 1 over 2 sine u du d theta. Yeah. Now it's really simple to solve this one. Maybe 0, pi, and I'm going to take the integral of this one is going to be sine to the minus cos r square. Right, we substitute the value, and then it's going to be 3 0 d theta. We can also know that from here it is du equals to r dr. Du equals to r dr. This is what we use to substitute here. Okay, I'm done this one. Let me just simplify this one, substitute the value. So it's going to be pi to 0 minus half cos 9 plus half theta. Okay. Now here, I'm just going to be going here, and due to crunch of space, I'm going to take integral. So now I'm taking the integral with theta plus half theta and pi 0. This one is equal to minus 2 cos 9 plus pi by 2, and then minus 0 minus 0, you know, theta has become 0, everything becomes 0, so we don't write it. Maybe I can write like minus 0. Okay, let's simplify this further. Pi by 2, I'm going to take the common, 1 minus cos 9. Okay, and that is pretty much I have. I cannot solve it further. Let's take a look on another problem. Evaluate integral three x dA over the region r equals to, now r and theta here directly given in the form of, you know, the in the form of wording. So you have to solve this range and put the limit accordingly. So r and theta such that r is going to this limit and theta is going to pi, so upper limit 0 is the lower limit. Okay, these are the two limits are given in the form of r and theta. This is a really simple problem. If you properly put in the limits, it's going to not be an issue. 3x dA. I can write like this. Theta equals to 0, theta equals to pi, r equals to 0, no, r equals, sorry, 1, and r equals to 2, and then 3. Then this x will be replaced by x equals to r cos theta. So I'm going to be writing r cos theta, and then dr, and then this dA is going to be replaced by r dr d theta. So r dr d theta. When we're solving with r, cos theta is a constant. So maybe I can write this 0 to pi. And when we remember, when we're solving r dr, the theta is a constant. So I'm going to be just writing the theta outside, cos theta outside. And r square, right? R square, so it's going to be r cube. And let me just change the parentheses so we can just write like this. 2, 1, d theta. Here I'm going to be further simplified. 0 to pi. And by the way, this cube, this 3 is divided, cancelling out the 3. So 1 over is going to be 3 over 3, so they're cancelling out. That's why it disappeared. Okay. From here, r cubed, so 2 times 2 times 2, 8 minus 1 is going to be 7. So I can write 7. Maybe just writing step by step. Cos 8 minus 1 d theta. So I can write like this. 7 cos theta d theta. Should be cos theta here. And the limits are 0 to 1. Okay, let's solve this one. So I'm going to say 7, then sine theta by 0. Sine pi is 0, sine 0 is 0, right? So if I substitute the value, everything will be 0 minus 0, the answer will be 0. Let's evaluate another problem. Evaluate the integral. The integrals are given like this: x squared minus y squared dA, where R is the unit circle of xy plane. Okay, is the unit circle of xy plane. So what does that mean? We already talked about the unit circle. Unit circle is a circle, have radius equals to 1. And it says xy plane, it means this is my xy plane. So R is going to go here to 1, R equals to 0, and is going to go all the way down here to pi. And this is 0, 0 to 2 pi. Okay. So we're going to write in those equations dA equals to R dr d theta, x squared plus y squared equals to R squared, x equals to R cos theta, y equals to R sin theta. The reason I'm writing those equations because we need one or the other, doesn't know when. Okay, I'm going to convert this. First I'm going to write like the way is given, and I'm going to convert it to my polar coordinate form. So I want to convert into 1 minus, this whole thing becomes minus, taking common is going to be R squared. This dA is going to be converting by R dr d theta. The range is given for R is going from 0 to, so R is my first limit, so R is going 0 to 1. The theta, d theta is my second limit, is going to be going 0 to 2 pi. Okay. Now I think it's fairly simple to solve this problem. So I'm going to be writing R minus R cube dr d theta. And it's going to be 1 over 2 R squared minus 1 over 4 R4 d theta. Values of the limits are given. I'm going to substitute the value. So this one is going to be half 1 minus 1 4 1 minus 0 d theta. I'm going to move to solve on the other side of the screen. So half minus 1 over 4 is going to be half. Half minus 1 over 4 is going to be, no, we have to substitute the values. So it's going to be, yeah, 1 over 4. 1 over 4, not half, 1 over 4. And d theta. And if I take the integral now, it's going to be 1 over 4 theta by 0. If I substitute the value, it will be It's going to be 2 pi, my bad. 2 pi, 2 pi. So it's going to be 1 over 4, 2 pi minus 0. And we can write here pi by 2. That is my answer. Let's take a look at another problem. It's a little bit different problem. It has two kind of limits are given. And let's take a look at how we're going to solve this one. Okay, so evaluate the integral. Integral is given like this, where r equals to such that 1, this value square plus y square, which is really an r square, equals to, this is the first condition is given, and second condition, x equals to less than and equals to 0. Okay, so what does it mean? First of all, we need to draw this. So let's take a look. 1, this is a 1. So I'm going to read out this thing and call r square. Okay, so really if I make the square root, it's going to be equal to something. But what I'm going to do, I'm going to be just leave it as is. So in this one, looks like this equation of circle is go from starting from 1 and ending for r. Starting from 1 and ending from r. So I'm going to make the circle. So I have a circle. And then I'm going to be make sure that I starting from 1 to 4. So it looks like I have another circle. Because starting from here to there. Let me just do it a little bit. So I have to draw another circle. Here, if I'm going to make a line, this line is going to be going, some other color maybe. This line is going to go from here to there. Here, r equals to 1. Here, r equals to, if I'm going to be putting this one, r equals to 2. Because r square to 4, so r equals to plus minus 2. So I'm only using the 2. So this is r equals to 2 at this point, and r equals to 1 at this point. That's one condition. Another condition for x, which is x equals to here, 0, right? So now I'm going to say x equals to positive. X is positive here, x is negative here. In this problem, there is conditions given for x, and what is the condition given for x? X should be less than equal to 0. Less than or equal to 0 means we can only consider this area, and we have to ignore this side. right? Because x is less than equal to 0 this side. Here x is bigger than equal to 0, so I cannot use this one, right? This is my, so really what is we have to do, I need to use a shaded area that I'm about to shade, and that is my goal to solve this one. Okay, yeah, so everything is given now. It's a fairly simple problem now to solve it. Just so you know, we need to write those expressions that we used to write, because we have to use them here and there, just like we did earlier. We used our x squared plus y squared equals to y squared. So I'm going to be writing dA equals to r dr d theta, x squared plus y squared equals to r squared, x equals to r cos theta, y equals to r sine theta. I'm going to be writing the expression is given before I transform this. I can like writing this expression easily, but let me just write here. We didn't talk about theta much. It is obvious, but I just want to make sure it's going from where to where. So theta at this point equals to pi by 2. And if you go all the way down, like this way, all the way down here, theta equals to 3 pi by 2, right? From 227 or 270 degree, this is 3 pi by 2. And 90 degree is pi by 2, right? 90 and 270, I can convert into radians, and these are the limit I'm going to be putting over there. Okay, I'm going to come here and writing here r cos theta plus r sine theta. I just substitute the values, and r dr d theta. Let's put the limit r equals to 1, r equals to 2, theta equals to pi by 2, and theta equals to 3 pi by 2. In this problem, we can solve it. I think when you do solving the r, the whole theta is considered as a constant. So maybe I can just write like this. And I'm going to be writing pretty much pi by 2, 3 pi by 2. And I'm going to be just writing cos theta plus sine theta. And I'm going to take the integral for 0, sorry, not 0, 1 to 2. R square dr d theta. I don't like to write these cos theta sine theta outside the integral, because, you know, in the end of the day, we should be consider this is still a part of the integral. We just need to solve it later. Okay, don't write outside is the best thing to do. From here, I can just write r cube 1 over 3. So I can just writing again r cube 1 over 3. 2 and 1. And inside this other parenthesis, I'm going to say is cos theta plus sine theta d theta. Okay, let's substitute the value. It's going to be r cubed, so 2 times to the 8 divided by 3 minus 1 divided by 3. So 8 divided by 3 minus 1 divided by 3. Okay, going to solve this. So this one is going to be 7 divided by 3. Okay. And inside the parentheses, I'm going to take the integral. Since I have a limited space, I can just take the integral right now. So I'm going to remove this integral and take the integral. So cos is sine theta minus sine theta is minus cos theta. Integral minus cos theta. And 2, 3 pi by 2, and then pi. If I substitute the values, it's going to be solving. The answer would be minus 14 over 3. The answer is going to be, this one is only going to be 2, minus 2 pi. So you take the minus 2 pi here to multiply by 7. It's going to be 17. And 7 times 2 will be 14 divided by 3. And that is my answer. Thank you for watching Knowledge Academy. Please subscribe my channel.